Hello everybody, welcome to the second part of the basic skills test. Let me get my pointer up. So we're mostly dealing with percents, decimals, and fractions, starting with fractions in this part of the review. You'll have to maybe turn the volume down just a little bit. Okay, we can write fractions in different forms, and we can also write fractions, decimals, and percents, each in the form of the other, since they all represent parts of a whole. So let's first talk about how to write fractions that are equivalent. Okay? So if you have equivalent fractions, they can be reduced to the same fraction when they're in lowest terms. So we reduce a fraction by taking the numerator and the denominator and dividing out a common factor from both. Okay, so when I reduce these 5/10, if I divide the numerator and the denominator by 5, it reduces to 1/2. 6/16, both the numerator and the denominator are divisible by 2. This reduces to 3/8. 15/32, there is no common factor, so 15/32 is in its lowest form. 12/64, I can divide the numerator and the denominator both by 4, which reduces the fraction to 3/16. And then finally, 300/800, both the numerator and the denominator can be divided by 100, which reduces to 3/8. So to answer the question, which of those fractions are equivalent to 3/8, okay, well certainly 5/10 is not. This one is, however, 6/16. 15/32 doesn't reduce, so it's not equivalent. And 3/16 is not equivalent to 3/8. But this last one, however, is. So our correct solutions are 6/16 and 300/800. They are both equivalent to 3/8. Now, when I want to model a fraction, I can model that fraction or its equivalent. Okay, but what I have to have is equally divided parts in my shape, if I have a shape, and then the correct number of those parts shaded. On the number line, I can just read where I'm at when I go from left to right. So in A, I have 3 equivalent parts. 2 of those are shaded. That works. Same thing for B. In C, I have 2 parts shaded, but they're not 6 equal parts. There's only 5. So it's not equivalent to 2/3, or doesn't represent 2/3. And in D, I don't have everything divided into the same areas. So technically, I really can't tell what that is. It may look like 2/3, but I can't assume that it is. And then finally, on the number line, I'm going over 1.5. Okay, 1.5 is 3 halves, not 2/3. So A and B are the only correct answers. Okay, now I have a set of numbers, and I want to order them from smallest to largest. Now, you may have learned to do this by converting each of the fractions to decimals, but I'm going to get a common denominator. So we've already talked about least common multiples. So I'm going to get a common denominator. So I want to find a common multiple, if not the least common multiple. And then I'll change each fraction to its equivalent with the same denominator. So the denominator, that 3 8, 5, and 9 will all divide into would be 360. So 5/8, in order to get 360 in the denominator, I have to multiply 8 by 45. Then I have to do the same thing to 5, so this turns out to be 225 over 360. 5/9, I have to multiply 9 by 40 to get 360, so 5 times 40 is 200. 3/5, I have to multiply 5 by 72 to get 360, as long as I do the same to the numerator. For 2/3, multiply the top and the bottom by 120 to get 360, and I end up with 240 in the numerator. And then for 2/5, we know that 5 times 72 gives me 360, so 2 times 72 is 144. So now I order them according to the size of their numerators, since they have the same denominator. So the smallest one would be 144 parts out of 360. And then the next smallest would be 200 out of 360, and following that, there I have their orders. Now, I'm going to write the answers not as equivalent fraction, but as the original fraction, the reduced fraction. So the smallest, of course, would be 2/5, and then 5/9, 3/5, 5/8, and 2/3. Sometimes we have improper fractions. An improper fraction is a fraction in which the numerator is greater than the denominator, so it actually represents more than 1. So we have a whole number part, and then we have a fractional part, and we can write any improper fraction that we've looked at so far, or any, as a mixed number. Okay, so let's do this first. I think it's easy to go this direction first and then understand why we go backwards the way we do. So 21/5 is improper, right? But a fraction bar just means division, so this is 21 divided by 5. So 21 divided by 5, 5 goes into 21 4 times and then has a remainder of 1. And this is how we wrote the answer before. But 4 remainder 1 is not a number. Okay? 4 remainder 1 is the relationship. To write this as a number, we keep the whole number part and write the remainder over the denominator. Okay? So we divide the numerator by the denominator. Okay, subtract to get our whole number part, and that gives us our whole number part. Then we subtract to get our remainder, which we put over the original thing we divided by, which is 5. So if we want to go backwards and change a mixed number to an improper fraction, we do the opposite. We're going to multiply these two numbers. Remember, this is what I got when I divided before. So now I'm going to multiply the denominator times the whole number part, add on the numerator, and that's going to give me the numerator of the fraction, and the denominator will be the same denominator we started out with, which is 8 in this case. So I'm going to take 3 times 8 plus 7 and put that over 8, which turns out to be 31 over 8. If I can reduce that, I would, but I can't, so I'm going to continue. Now, here we have two problems where we're adding fractional numbers. Okay, in the first one we're adding proper fractions, and in the second we're adding mixed numbers. So when we add fractions, we have to get the same denominator, and then we can add the numerators and keep the same denominator. and always reduce your answer if possible. So 3 over 8 and 1 over 5. The smallest number both 8 and 5 will go into is 40. So I want to rewrite these with 40 as the denominator. So the 3/8, I have to multiply the numerator and the denominator by 5 to get 40 in the denominator. And then the 1/5, both the numerator and denominator have to be multiplied by 8. Okay, so after I do these multiplications, now I have a common denominator. So I can add the numerators, keep the same denominator. So I get 23 over 40. I would reduce this if I could, but I can't. So that's our solution. Now the B part, we want to express our answer as a reduced mixed number. The easiest way, I think, to add mixed numbers is to change them to improper fractions first, then get a common denominator and go through the whole process. You may have learned to add the whole number part and the fraction number part, but I'm going to do it the other way. Okay, so I'm going to change 8 and 4/9. So 9 times 8 plus 4 over 9 turns out to be 76 over 9. 3 and 3/5, 5 times 3 plus 3 is 18 over 5. Now I need a common denominator. Well, the smallest thing 9 and 5 will both go into is 45. Okay, so I'll multiply the bottom 9 here in this denominator by 5 as long as I multiply the numerator by 5. Here I multiply the 5 by 9 as long as I multiply the 18 by 9. So I get 380 over 45. And then this turns out to be 162 over 45. Add the numerators, keep the same denominator. And I have 542 over 45. Well, we were given the instructions to express the answer as a reduced mixed number. Okay, so when I do the division and then reduce the fractional part, this turns out to be 12 and 2 over 45. Now I'm going to take the same and do subtraction. The nice thing about subtraction is the only difference is you're going to subtract the numerators, keep the same denominator, and then reduce. Okay, so we already found what these equivalents are. So we found that this was 15 over 40, and this was 8 over 40. So when we subtract the numerators, keep the same denominator, we end up with 7 over 40. Here, again, we already found what these were as improper fractions, so we subtract the numerators and change our answer to a mixed number, 45 into 218, and it reduces down to 4 and 38 over 45. Multiplying. The nice thing about multiplying is we could get a common denominator, but we do not have to. Okay, so when you're going to multiply these fractions, you multiply the numerators together to get your new numerator, multiply the denominators together to get your new denominator, and then you reduce. So 3/8 over 1/5, I don't have to rewrite those. I just end up with larger numbers to have to deal with and reduce if I did. So when I multiply the numerator, I get 3, and the denominators I get 40, and that does not reduce. Okay. Multiplying these, I'm going to still change them first to improper fractions, which we've already done that. And now I don't have to get a common denominator, so I'll multiply straight across, which gives me 1,368 over 45, which when changed to a mixed number and reducing the fractional part is 30 and 2/5. Division. Also, again, we don't have to get a common denominator, but to divide means to multiply by the reciprocal. Okay? So, what we have to do is rewrite the division problem as a multiplication problem, and then reciprocate or invert the second fraction and follow our multiplication rules. So 3 over 8 divided by 1 over 5 turns out to be 3/8 times. Change the operation to time. Invert this fraction. Now multiply and then reduce. Now it says as a reduced fraction, doesn't say mixed number, so we can leave the answer like this. We knew what the improper fractional equivalents were for these. So I'm going to use those, change this to multiplication, and invert that fraction we found. Okay, so we found that this was 18 over 5, but I changed this to multiplication and flipped that upside down. Multiply straight across. I get 380 over 162. And I want to reduce mixed number, which turns out to be 2 and 28 over 81.